Now that we've completed our drafted wheel design, let's focus on the drafted wheel 3-part file. Now, before this goes any farther, we want to make sure that we evaluate what we've done. And SolidWorks has some tools for us. The first thing we want to do is right-click on one of the tabs and make sure that we activate either the Mold Tools or the Evaluate option. Now, if you go to Evaluate, you'll see a section that has Draft Analysis, Undercut Analysis, and Parting Line Analysis. If we right-click and we turn on the Mold Tools, inside here, we also have Draft Analysis, Undercut Analysis, and Parting Line Analysis. These are the exact same tools, just located in 2 different places. So I'm going to right-click, turn the Mold Tools tab off, and simply focus on Evaluate. The first thing we want to do is go to Draft Analysis. We're going to select the plane that we want to pull from, in this case the front plane, and we're going to select the draft angle. Now we want to say a minimum of 1 degree. So as we're looking at this part, you can see that we have green faces and red faces. Now there's a color settings section in the bottom of the window, and you'll notice that we also have gradual transition. Gradual transition is great for very complex outside shapes that might go from positive to negative draft. But for a simple part like this, we want to make sure that we leave positive, negative, and requires draft as 3 separate colors with no transition between them. We can go ahead and select OK, and this will stay on. You'll notice that you have a color bar key in the bottom right-hand section, and you'll also notice that in your Evaluate tab, Draft Analysis is now a depressed button. If we select that, it'll turn the colors off and you'll go back to your gray shaded model. So as we look at this, the important things to note are the red colored areas are all on the same side. So that means anything in red has a draft angle that can be pulled from the back side. Anything in green has a draft angle that can be pulled from the front side. As we look at this, you want to make sure that you don't see any red. Anything you see should have green on it. So as we look at it, everything is fine from this view. We turn it around, everything is fine from this view. Now, again, you want to rotate it around, and the big areas we'd be concerned with are faces like this, which might have an undercut or an occlusion. All right, let's go ahead and turn draft analysis off, and let's focus on undercut analysis. Undercut analysis will again use the front plane and take a look at everything that we have here. You'll notice that with this tool active, on the left-hand side, we have direction 1 undercuts 64. Direction 1 is giving us this lighter blue color. Direction 2, 67, which are the darker blue on the outside, and everything looks fine. All the color transitions happen at a sharp edge, or really this is going to be a parting line edge, and you'll notice that there's no occluded or straddle regions. Now these are the regions where you would potentially run into problems. If these edges, for instance, had a negative draft and then a positive draft, you'd have an area of occlusion that couldn't be pulled with a straight pull mold. You'd need to have some sort of sliding core, some additional functionality. Now, for a simple part like this, if you can get around that in a design standpoint, if you don't need to have those faces go into an undercut or an occluded area, then by all means avoid it. Now, this is a good final test to make sure you didn't accidentally make a mistake during the design process. We know so far that using draft analysis and undercut analysis that everything is fine with our part. We don't have any areas where we need to have additional draft. We don't have any areas that we have an undercut or an occlusion that we need to go back to the design and redesign or change anything. Now, the reason that we know that everything is designed properly is because we used the most basic process. We did an original extruded boss. We used draft that was set up in our equation manager with a global variable. And any cut that we did or addition that we did after that, we made sure that we used the draft tool so everything had draft. Fillets were added after the fact, so they wouldn't have changed anything in terms of the draft angles. We shelled the part, so we know that any draft that was on the outside is also on the inside. So we didn't have to worry about any undercuts or occlusions because of tools like thin extrude or anything like that. Then we added a rib. We also made sure that we added draft to that rib when it was done. Again, fillets were added that don't affect the draft because they were done after the fact. And then we patterned and cut features, again, with draft on them to make sure that they were going the appropriate direction. So at this point in time, our part is now completed. We made sure that everything was done. We can go ahead and save it just to be sure. And we've completed our first drafted or molded part.